Number 3 says, evaluate the limit using the limit approach method. The limit as x approaches 0 of the function square root of 2x plus 4 on the outside minus 2 divided by x squared. All right, so the limit is approaching the x value of 0. So that means we have to take the limit from the left and the limit from the right and see what we get. Okay, so over here, we're going to do the right limit. And over here, let's put that in red, we're going to do the left limit. So this is going to be the limit as x approaches 0 from the right of the square root of 2x plus 4 on the outside minus 2 divided by x squared. And over here is going to be the limit as x approaches 0 from the left of the square root of 2x plus 4 minus 2 over x squared. So values that are approaching 0 from the right. So they must be positive, but getting closer and closer and closer to 0. So we'll start off with 1, 0.5, 0.1, 0.01, and 0.001. And what we're going to do is we're going to plug these values into the function. So for example, the first one, that's going to be the square root of 2 times 1. Make that a little bit better. Put that in black, actually. The square root of 2 times 1 plus 4 on the outside is minus 2 over 1 squared. And let's take 6 numbers after the decimal when we do that. Make this a little bit bigger. Now I'm going to put here parentheses square root of 2 times 1 plus 4 on the outside, that's minus 2. Close that up. We're going to divide that by 1 squared. 0.449490. 449490. Okay. Then we're going to do the same thing for the next one, except we're going to be putting in 0.5 into the function. Let's delete that. Put in 0.5 into the function. And there's our new answer. Approximately 0.944272. We're going to replace that and put in 0.1 into the function. That's going to be 4.939015. We're going to put in 0.01 into our function. Approximately 49.937655. And then after that, we're going to put in 0.001. Approximately 499.9375 1, 6. All right. Now, let's look at the limit as x approaches 0 from the left. Let's close this up. So if it's coming from the left, that means it's going to be negative numbers because it's less than 0, but getting closer to 0. So -1, -0.5, -0.1, -0.01, -0.001. And let's see what we get. So we're going to plug in -1 into our function. That's going to be the square root of 2 times -1 plus 4. On the outside is a -2. And that's divided by -1 squared. So in our calculator, let's just delete the inside of this. Let's put -1 in the inside of the parentheses. And we're going to do the same thing down here. Put in -1. So our first answer, that's going to be approximately, let's zoom out a little bit, -0.585786. Okay. Then let's put in -0.5 into our function. So delete that, put in -0.5. Delete this, -0.5. That's going to be approximately -1.0717. Let me see. 2, 4, 6, 7. There we go. We're going to plug in -0.1 now. And that's going to give us approximately -5.064113. -0.01. -50.06265. Well, -50, 06, 2666. Yep. Because this 6 right here will make that. You know what? Recount. Let's recount that real quick. -50.062657. And let's plug in -0.001. And that gives us -500.062516. I don't know if you guys can hear that, but the rain's hitting my AC. Anyways, as we can see here, this limit does not exist. Because if you evaluate this as the limit as x approaches 0 from the right, these numbers are getting bigger in the positive direction. But if you look here, as the limit as x approaches 0 from the left, the numbers are getting more negative. -0.5, -1, -5, -50, -500. While this is going up. +0.4, +0.9, +4.9, +49.9, positive 499.9. This here, these values are going to positive infinity. These values are going to negative infinity. Because the left limit doesn't equal to the right limit, the limit itself cannot exist. All right, guys, so that's the answer to the question. The limit does not exist. I'll catch you in the next one. Take care.